Hi, here we are, EOC review number 14. So it says, what is the equation of a circle with a radius and a center? So Pythagoras had found that in a triangle, and there's like a triangle living inside this circle, that if my hypotenuse is my radius, then this would be my x-coordinate, right? And this would be my y-coordinate. So what we're looking for here is that these x values, this would be x if this coordinate here would be in the center. But if I moved it, it would end up being a number here. Okay, so that would be the x value, is whatever the number is there, and it's actually minus that number. So some people think of it as kind of lying. Okay, and then in this my y value, whatever the center value is would be there. And then you see that the radius, x squared plus y squared equals the radius squared. This is our generic formula for a circle. Now as we look here, if the radius was 3, then it would be the formula radius 3. So I'd have 3 squared. Then it says center at 3, 0. So if the center here was at 3, then this would say x minus 3. And if this y-coordinate was 0, then that would say y minus 0. So I could rewrite this. This would look the same. And you see how this is all multiplied out? So I need to kind of multiply this out. So this here would be, if I changed the way this looked and I went ahead and squared it, so an exponent means take this item, this stuff, and multiply it by itself that many times. Here, y minus 0, or y minus anything for that matter, would still be y, so I could write it like that. And then this I could write as 3 times 3, or 9. Okay, so it doesn't look quite like any of my choices, but I'll keep going. So I have x squared minus, and then negative 3 times x would be negative 3x. So I distributed these two, and I distributed these two, and so I distributed, or you could think of as I distributed this x to both, and now I need to distribute this to both. So I need to get this one and this one and this one and this one, right? So negative 3x, and then negative 3 times negative 3 is a positive 9. Okay. So this is what it's looking like, and it's starting to look like what I'm expecting here. So I got x squared minus 6x, and then I have plus 9 on both sides. So if you think about this, if I subtracted 9 on both sides, I'd just have that. So let's see if that's anything. Oops, and I forgot this y squared. So that I just forgot to copy down. That's supposed to be here with these guys as well. So y squared. And so I need these 3 terms added together, an x squared, a y squared, and a negative 6x. An x squared, a y squared, and a negative 6x. So I'm going to pick A. Another way to do this is to type each of these into Desmos, and then that would tell you which one's accurate. Cool. Okay, next question. It says, given circle W, what point lies on circle W? Okay, so that's pretty cool. Couple ways to do this. Which point lies on circle W? So I think the best, easiest way to do this is by graphing. So if I had a piece of graph paper, or even a piece of notebook paper, I'm going to graph this at negative 4, positive 6. So back 4, up 6. There I go. Okay, so I went back 4, negative 4, and up 6, and made a dot. Now it says my radius is 10. So that would mean 4 and another 6. 4, 5, 6. Okay, that would be a dot. So that's 6, 6. That would be on my circle, right? So here's my center. And to make my circle, I'd go 10 to the right, 10 to the left. But if I went 10 to the left, I already went negative 4. And so 10 more, this dot over here, I just made that extra line, would be negative 14, 6. So I have 6, 6. I have negative 14, 6. I also have 10 up and 10 down. So if I went 10 down, this would be 6 and another 4. So 1, 2, 3, 4. So this would be at negative 4, negative 4. So my circle is starting to take shape here. I have a circle at negative 4, positive 6, and definitely have a radius of 10, but none of these coordinates have shown up. So I can decide who isn't on here. If I look at coordinate 0, 4, so if I don't go left or right, but I go up 4, that is not on the circle. So A can't be right. 2, 10. 2, 10. 6, 7, 8, 9, 10. 2, 10. Also does not, see how that distance is not 10. So that's not on the circle. 4, 0. So 1, 2, 3, 4, 0. Ooh, that got pretty darn close to where I kind of sketched my circle. So that one's close. Now let's look at this one, 6, 16. 6, 16. That looks too far away. So the only one that actually looks good is 4, 0. So let's try that out. I'm going to make, because there's 4, 0, right? That's 4, 0, 4, 0. This distance would be 4 and 4, so that would be 8. This distance we know is 6, and this is 10. That's the most famous triangle of all time. So this one is definitely on my circle. You could have also used Desmos and notice that that point was on your circle. But you might be thinking, well, how did Miss Krusemark know that was 10? Well, I counted this off as 8, and this is 6, and this you don't know. So 6 squared plus 8 squared equals this distance squared. Wait, 8 times 8 is 64. 6 times 6 is 36. If I add these together, I get 100. And so hopefully you're figuring out, Miss Krusemark figured out that that is 10. And we wanted our radius to be 10, and it was 10. So that would land on the circle. Cool. So it's not just close, it's exactly right. Okay, question 6. The equation states, so I look from here, I already know my center has to be at 1, 3, and it says I don't know the radius. Point B lies on the circle. What is the radius? Interesting. So if I think about this, I have something at 1, 3. So I'll go over 1 and up 3. And then I know the point 4. 1, 2, 3, 4, 7. So I already went up 3, 4, 5, 6, 7 is on the circle. So 4, 7 is on the circle, and 1, 3 is the center of the circle. And so I need to find the radius. So we can use the distance formula. The radius would be the distance between these 2 points. That would be totally okay. Or I could just use my graph paper. I know that this is 1, 2, 3, because I went from 1 to 4. And I know this is 4 because I went from 3 to 7. But again, some students are more comfortable with the distance formula, and I think this is great practice. More than one way to solve it. So the two x values, I subtract 4 minus 1, and I get 3. And so that's where that number came from. And now my y values, 7 and 3. I could subtract the two y values, 7 minus 3, and I get 4. So that's where that number came from. And I think you might realize I'm going to get the number 5 here for my radius, because 9 and 16 would add together to get 25, and the square root of 25 is 5. Cool. So that's what I got for B. Next one. What is the equation of a circle that passes through this point and is centered there? So once again, I know from my last one, if I know the location of the center and I know a point on the circle, then the distance between those has to be the radius. So my radius is my distance formula, which is equal to, okay, so subtract my x values, 5 and 2, and square it. Subtract my y values, 6 and 2, and square it. And wow, you know, I talked about this being the most famous triangle. It's a 3, 4, 5 triangle. So 9 and 16, I get square root of 25. So once again, I get 5. So I know my radius has to be 5. So, but this one can't be right because, again, remember, based on my generic formula, it's radius squared. So that's looking good. I also know that my center is at 5, 6. And so maybe I could have already solved this knowing that this has to be my answer because that is the center already. Okay, last one on this side. It says, what is the equation of a circle with a diameter at these endpoints? So now what we're looking at is 1, 3. So maybe it'll be easier to graph it with graph paper over to the side. 1, 3. 1, 3, and negative 3, positive 1. So this is my diameter. Pretty cool, right? So that means that my center is here, and my radius is just half as far. So let's think about this for a minute. This would be what my circle would look like, something like that. So I have a point here, and I have a point here. And as I said, this point is at 1, let's look over here, 1, 3. And this point is at negative 3, positive 1. So this distance should be the negative 3 and a positive 1, so this distance should be 4. And this distance, I went up 1 here, and then to get to this point, I went up 2 more. So this should be 2. All right, and notice that is the distance between the y values. So I can use the distance formula, but again, be careful because that's actually the distance between these points is the diameter. So if I use the distance formula, I subtract the x values, 1 minus the negative 3, square it, so that's 4. Once again, my picture gave me the number 4 anyway. And subtract the y values, 3 minus 1. So 3 minus 1 and square it. So that's 2. So that's where that number 2 came from anyway. I'm going to end up getting not a perfect number. So that would be, so I get the square root of 20. So my radius would be half of the square root of 20. So that's my radius, because my diameter is the square root of 20, so that's half of that. So let's think about, at the end of our equation is radius squared. So let's try to square this. And that's where our fancy online calculator is going to be really handy. So if I take the square root of 20, this isn't the fancy online one, but you can type it just in there. The square root of 20, divide by 2, and now I want to square it, and I get the number 5. Cool. So this squared, the radius squared is 5. So this has to be either C or D. So now let's think about what point would be in the middle. We get to use our midpoint formula. So if we think about our midpoint formula, that means you add, or you can look, if I look just on my chart here, it looks like my midpoint would be at -1, +2. So if my center is at -1, +2, then these signs will be flipped. Okay, so there's our answer right there. Thanks for joining us. Check out the next video for the other side of the sheet.